right, everyone. Welcome to the NEXUS Podcast. I'm Chirag Patel. I'm at Harvard Medical School and also a co-PI of the NEXUS, the network of exposomics in the United States. I'm here with my great friends and collaborators and amazing co-authors of our recent paper published in Nature Medicine called an Atlas of Exposome and Phenome Relationships in Health and Disease Risk. Super exciting time to be with you guys here in outside of Barcelona at the Exposome Forum. What has caught my eye is the advances that exposomics has made in the last decade or so, kind of around when we started making ideas about this project. Guys, what do you think about it, and how far we've come in these 10 years and kind of its manifest in this paper? I'm super proud of the result. I'd love to hear what you guys think.
Yeah, no, great to be with you, Chirag and John, and I think it's always fun when the three of us get together in person. I think you also revealed that I think this did start about 10 years ago, so papers can always get published. I think it is one of the lessons of this as well. I think in many ways the questions that we were asking 10 years ago when we started this project are just as relevant today, and those questions are how reproducible, how stable, how robust are our associations of exposome and phenome, right? And so this is an attempt at being systematic, at being large-scaled, at being really sober in our appraisal of how the exposome associates with the phenome systematically. And so the data set that we chose 10 years ago, right? In a way, like the whole world has changed in the last 10 years in many ways. But the data sets that we're using, so this is NHANES, National Health and Nutrition Examination Survey, to power this study. They're the same data sets that I think I would choose today if we were starting with the same set of questions. How do we make nationally representative, robust estimates for an initial atlas of associating exposome with the phenome, where we have measurements from repeated surveys, we can understand sort of how these things are stably associated over a large period or not, and how can we do this at scale? And so in a way, a lot has changed. We haven't even talked about AI yet, and it's been a minute into the podcast, so that's impressive. But we are, I think, asking still similar questions and still trying to use some of these great data sets to answer them.
Yeah. I think where places that we'd been inspired, I think a lot of it was born from John's work in meta science, meta research, and trying to get a handle on when things get fragmented, what are the implications of that, and
right.
In terms of associations that we deem or assume to be important, but maybe in the whole scheme of things, not so. John, can you tell us about your view on why things get fragmented and how our work maybe pokes at the problem a little bit?
I think it's the incentive structure that is really incentivizing papers that are thin salami slices and least publishable units. And I think that there has been an entrenched tradition of trying to look at one association at a time or a few associations at a time. In fact, as we get more sophisticated analytical tools with AI, now you can create literally thousands and millions of papers of these least publishable units.
Yeah.
And we've seen that even with NHANES in particular, which is one of the most robust databases. We've seen it with other robust databases like the UK Biobank. So the evolution of technology and methodological options has allowed us to get this larger bird's eye view. At the same time, has made the fragmentation even more prominent.
Yeah.
And I think we're reaching a point where we need to decide, which path science is going to take. Are we going to take a path of more sober and systematic and reproducible type of research versus just flood the literature and ourselves with little bits and pieces that make very little sense eventually?
Yeah, I totally buy into that vision. Raj, from your AI and also genetics vantage point, how can we start bringing these things together? It could be AI, but as you alluded to earlier, it could be things like measurements and new study designs. and databases.
Yeah.
What's the future look like?
Yeah, I mean, I think as in 2016 when this started, and then 2006, I think when John's legendary paper that we still read
Was it
several
2005?
times a year.
2005.
Okay. See, off by 1 year. Just, 10 base 10 bias, right?
It's a rounding error, and how many times it's been
rounding error.
downloaded.
Almost 20 years ago, why most published research findings are false, right? I think the important sources of variation, right, that we pointed to, that John pointed to in 2005, the incentive structure, the bias that's present in what gets published and what gets even submitted and what gets buried in the file drawer. And then for another paper that I think we also should publish that is also reaching a significant maturity, I think there are a lot of challenges around these shared data sets where there's many investigations that are happening and only a small fraction of these that get eventually published or submitted, or very little attention to multiplicity burden across the sort of communal set of analyses across these shared data sets. I think, Chirag, what you said, measurement is still paramount, right? And I think we saw that in our study too, right? If you look at some of the serum biomarkers that were measured and their associations, I think we generally have a little bit more confidence, or to much more confidence than some of the questionnaire-based measurements. And this is not to say that questionnaire-based measurements are not important. They are, but they could be revealing of many different things that are not necessarily the thing that we're intending to study.
Yeah.
And also super relevant for our this field that we work in, and Chirag, that I credit you for bringing me into, and then John for initially virtually mentoring me and then actually mentoring me in this field, is the way in which we're measuring them cross-sectionally versus longitudinally. And so I think there's really interesting associations we saw with, for example, FEV and pulmonary function measures in the paper, but we're only using cross-sectional data, right? We don't have data from the life course. We don't have early exposure data. We know these are critical for some of these phenotypes that are associated with respiratory function, but we have very little in the way to measure that. I think that's still just as relevant how we measure it. For AI, as you know, and I don't know if the listeners will know this fully well. And John, I don't know if you know this about Chirag either. So let me also, Chirag has I'm pretty far on the AI is transforming everything we're doing in science spectrum. I think Chirag might be even further than me. He's, which I think is a
psychosis we can talk about later.
Psychosis. Okay. So Chirag is full AI psychosis. And so even this paper, so this Nature Medicine paper, I think we realized, started 10 years ago, LLMs were not a popular term that was used by the average scientist. ChatGPT was not a household name at the time. And even when we started the project, I think even after the ChatGPT moment, after the growth in LLMs for the last few years, and the tooling that's been built around it, I think it didn't really transform until maybe the last year or so our actual workflows. And so there's some tools in particular like Claude Code and some of the agent-based like Codex, that have, I think, really made clear how much carefully steered AI tools can conduct very serious analysis. They can also go astray. They can also produce anything you want. And they're tools, so they can be directed for, and they're often very responsive and sycophantic almost. They can be directed towards what your bias is, right? And just providing maybe the most sophisticated evidence for reaffirming your bias. But I think what we've seen in this project, and it wasn't part of this paper, but we realized it kind of as towards the tail end of this, is that I think, Chirag, you'd agree, we can largely automate what we did here with careful supervision in terms of the analysis. Yeah. And that would have been science fiction for me just, even 2 years ago, to even think that software could be written by an AI that is directed by us, largely in natural language, to produce largely the same conclusions in the paper. And so I think these are tools. They can be used for good or for bad. We do have a choice. I hope we choose the reproducible side of this. I mean, I think also, John, you're right, there's an incentive structure that I think still exists very strongly to sort of published LPUs, least publishable units. But maybe we can use these GPUs to try to publish large-scale sober analysis as well.
I think the carefully steered is the
It's
term that
is a caveat that's doing a lot of work.
So critical.
Yeah.
It's fascinating. I agree. I mean, some of our workflows can be enormously facilitated and taken to scale, and I'm also very enthusiastic about it. But at the same time, I've seen so much misuse, and it's an interface between these new tools and their users. And I think many of the users usually are not prepared to handle that advance. And I've just seen it's not so much an issue of whether someone is smart or well-intentioned. I've seen extremely smart people generate outputs with AI, sophisticated AI tools that are completely unbelievably wrong. In ways that I could not have imagined that one can be.
You've probably seen humans
so
do that
wrong.
too, right? You've probably seen humans unassisted by AI do that as well, though, right?
Of course, but
it's different.
There's a multiplicative effect on the magnitude and also the distortion of the error, because it can look extremely sophisticated. In the past,
and it's getting better. That's getting better. The ability to delude is getting better.
Oh yes, and it may not be intentional. It may be that someone goes down a track that is not really familiar with some fundamental principles and some assumptions that are built into just step one.
Right.
So somehow you get these magnificent structures that are built on thin air, because there's no attention to some basic assumptions. So I'm very enthusiastic. I probably equally, if not more, enthusiastic about what we can get. It's just that I think we also need some very rigorous foundational understanding of methods, assumptions, principles that I feel that somehow they're taken out of the mainframe at the moment. Because of the excitement. People say, "Oh, look at this! It can do all of that I wouldn't be able to do in a year. It does it within seconds."
I totally agree, and I think maybe the broader point, or this is a good transition to education, to what's important for teaching, right? So we all teach at our universities, and we've been blessed now, where I think there's a lot of students who've sort of gone through training pre-AI that are still working in our labs and that we're working with, and they've developed, I think, John, if I'm interpreting you correctly, this domain expertise, this deep respect for the domain, for the methods that hopefully act as some type of either antibodies towards being aware of when you're going down that thin air, magnificent structure path, right? Or I'm thinking of the parable, right, of the garden forking paths, right? In a way, this is a tool to traverse that faster, and with more disorientation about where you are within that garden, and that's very scary. And I think there's, even in this time of AI where people are thinking about reshaping education, I just come back to I think what you said, John, and I think about this in the context of medical education as well. We still need deep domain expertise. Maybe we need even more than we did before to understand what taste is, to understand what a good problem, a good posed question is, and then to really guard against the unbelievable amount of confirmation bias that can be unlocked by using these tools and letting them tell you what you want to hear.
Absolutely, and I think that I'm not sure we are prepared for that. I think we're learning in the process, and we're redefining what we need to learn and how we learn and why we learn. So these are fascinating questions on their own. I mean, and I think that we need to think about, as you say, new generations of scientists who train with very different background, with very different prerequisites of what it takes to be a scientist, and how do you become a scientist? You have to think of new modes and new adaptable modes that would allow someone to continuously evolve along with the options, but not be overrun by the options.
Right.
That's I think the big challenge at the moment.
Do you think it's different, or it's fundamentally the same with medical education? So training doctors.
I think there's quite a bit of parallel here. Training doctors, has some additional dimensions, or has fewer of the dimensions of treating a computational scientist.
Right.
And, you need to learn dealing with people, for example,
Right.
and dealing with people in very different circumstances than the typical situation where you're just plugging new numbers and getting output. I mean, you have people who are in distress, people who are sick, people who are dying. Public health, you deal with communities, with their anxieties, with their priorities, their fears, their preferences, their sometimes even political or ideological stances. So that I think that goes a little bit further
Right.
in some ways. There's also the challenge when you try to educate physicians how much of that computational revolution you want them to digest, absorb, feel comfortable with. I mean, should they lead that? Should they follow? Should they engage? Should they somehow tolerate
Right.
that onslaught of information? And I think everything is possible. I mean, you've heard all these discussions about even physicians being replaced, and in many ways, yes, I think we can be replaced in many things, most things, all things. I don't want to say this, but we will see lots of challenges in the future moving forward, and some decisions that need to be made.
Yeah.
Who is doing what, and why are we doing it, and what are we trying to accomplish, both as scientists and as educators and as physicians in practice.
Yeah, and I think to me the emphasis you had on sort of methodological taste, right, for training computational scientists or statisticians, future data scientists who are analyzing these data sets and trying to write papers about the exposome. I think that there are, as you said, a lot of parallels with clinicians, but I maybe this is a bit of a unexpected take. I think medical school does a lot right, and I think the emphasis on, ignoring the Krebs cycle and all the standard like over memorization. I think the emphasis on learning sort of a deep understanding of developing deep understanding of pathophysiology, of a schema for thinking about disease generally, and then, as you said, of interacting with people, with patients in distress, eliciting histories, building trust. Those things that are emphasized, I think they're still going to be important, even if AI is offloading some of the work of a physician or superpowering our future physicians. And so that again, that domain expertise, that taste, that deep respect for the knowledge base in the field, I think that's going to keep being important, be much more important in the future.
But I come back to what both of you were saying is where I'm super optimistic about, and what I learned from this project is, in essence, what we embarked on, this XWAS thing, was a bias reduction exercise. In that it helped us understand the multiplicity or the number of hypotheses that could be tested in this particular domain, and realize where we may be wrong in those other studies that have maybe emerged that reported larger effect sizes or things that are biased or inaccurate due to other things such as confounding and phenomena such as those. That's where I'm optimistic about the large language models and AI, is that we do bring in with our problems, be it maybe treating a patient or a data science exercise, such as those candidate studies that have existed in the past that you talked about, these biases, of which in the process of automation, we may remove some of those. I think there are new ones that emerge, and studying those carefully, I think, is the next best thing. But I do think that there's hooks there for people to get involved with, and how we learn about the methods of old and how they plug in, as you're saying, to add taste. So I think if we view it as a bias reduction exercise or maybe a bias addition,
variance reduction exercise.
Variance reduction. I think I'm super optimistic.
I like that perspective. Throughout my life, I felt that I was starting to find effects, and then I was finding biases. So again and again and again. So any bias reduction or bias prevention or bias understanding, just trying to get it out of the way and then try to see what survives is really very important. I think that this type of work that we have done hopefully is going to be helpful in that regard. And the extensions can be even more powerful in this bias reduction.
Yeah.
But it also takes training. It takes a sophisticated user to be able to not fall prey to just the amazement of what these atlases would look like and the richness. I think we can easily drown in numbers, and I hope we won't.
Yeah. Vibration of atlases.
It's so amazing to be with you here. I'm so glad you guys came. I'm super honored to have you guys as colleagues and friends. So thanks so much.
Likewise. Yeah, and what an amazing venue too for discussing the exposome.
Yeah, Thank you guys.
It's been fantastic.
Thank you so much.
Thanks a lot.